Hello everybody. In this session, we're going to talk about how to avoid 10 common mistakes in code, specifically for the beginning Java programmer. Now, why should you let others review your code? You should let your peers or instructors review your code even if the behavior seems correct, meets the requirements, or the output seems correct. Now, because some solutions are wrong, even if the output or the behavior is correct. Wrong in the sense that coding conventions are not followed, you got the output correct by luck, etc. And there also could be better ways. When I say better, it means probably more efficient, more effective, faster way to solve the same problem. So by showing your apparently working code to a peer or to an instructor, they could point you to something which you would not have realized. Now the objective is this session is to find out what are the common mistakes made by newbie programmers, and of course, more importantly, to avoid making these mistakes yourself. I've listed 10 common problems. Let's look at them. The first common problem, what I call cowboy coding. Okay, the cowboy um, walks into the desert and shoots anyone he wants to shoot. Okay, he does anything he wants to do. He gives meaningless names to variables, methods, and classes. Alright, and makes it very difficult for people to understand, to guess what that method does or what that variable actually stores. A cowboy doesn't indent his code properly and makes it very difficult to read. A cowboy doesn't follow standard coding conventions. Now in Java, how do you choose names? Classes and interfaces. You haven't heard about interfaces yet, but well, classes and interfaces should start with a capital letter. Variables and methods should start with a small letter, and you should use camel notation. So in other words, if there's a variable name or method name which is made up of multiple words, such as text rate, the first character of the second or third word should be capitalized. So text rate will be small t, small a, small x, capital R, small a, small t, small e. Alright, that's a camel notation. And of course, for constants, we use all upper caps. If there are 2 or 3 words or 4 words in that variable name, in that constant name, we separate the words using underscore. Now, Cowboy does not comment his code sufficiently or excludes comments altogether. Makes it very difficult for even himself to understand what he's trying to do after 1 week. So, now I've seen good programmers, good in the sense that they can solve the programming problems, who do not follow coding conventions, who do not indent their code, etc. Now that's fine as long as there's no need for you to share your code. But as long as someone else needs to read your code, for example, if you're working in a professional software development team, you should follow coding conventions, you should indent your code, etc. It helps your team members to understand what you're trying to do without too much communication. For example, when I see a name which starts with a capital letter, I know it's a class. There's no need for you to tell me so. Okay, but having said that, remember that different programming languages come with their own set of coding conventions. Okay. Now, common problem number 2, comparing strings using the equality operator. This is the equality operator, 2 equal signs, instead of the equals method. So here's an example. Okay, I when the program runs, main runs, and it prompts the user to enter the word apple and uses the scanner's next line method to retrieve the input, stores it in this variable called input. Alright, now this is the correct way to compare strings. comparing the value in input with APPLE. The wrong way to compare strings using the equality operator. Now let's see if this works. Oh, this is problem 2. Okay, when I run problem 2, ta-da, this statement on line 12 returns false, even though the value stored in input is apple. This returns false. So for string comparison, use dot equals. Equals is a method of the string. Compile again, this time run it, and then type apple, it works. Now use the equality operator if you want to compare ints, integers, or chars, alright, but not for strings. Now, why is that the case? It's beyond the scope of discussion here. Okay, common problem 3, exiting a loop prematurely by using an else block. Let's look at an example. So I've written a method called contains char, which takes in a string s and a char c. So this method is supposed to return true if the character c is found in s, and false otherwise. So usual way to do it, the common way to do it, is to use a loop to go through every single character. Okay, so I is 0, this is true. Okay, I go in and I check the first character. S.char at 0, is it equivalent to C? If so, I go to run line 12, return true. If not, I jump to block line 13, go into the else block and run line 14 and return false. And the program doesn't seem to work correctly. Okay, for example, if contains char is called and I pass in apple with an L, it should return true, but in this case, it will return false. Simply because of this block. There's a problem here. This else block needs to be removed. This contains char method only checks the first character. Now, during the looping during looping, okay, it sets I to 0. This is true, it goes in and it checks for this condition. Char at 0 is equivalent to C. If so, it returns true. If not, it returns false. Once you meet a return statement in the method, it doesn't matter if this return statement is found in a loop or not. The whole method terminates and control is passed back to the caller of the method immediately. So beginners are probably not very aware of that fact. Once you hit a return statement in a method, the whole method returns, regardless of whether you are still looping halfway or not. This has to be removed, and the code will work. All right. In this case, if the first character does not match, it jumps to line 13, 14, increments I becomes 1, checks this is true, goes in and checks the second character. S.char at 1 is it equivalent to C. Still not equivalent, still no match. Comes to line 14, I becomes 2, this is still true, goes in and checks the third character. S.char at 2 is it equivalent to C, and so on. Now, if the loop finishes, that means it has checked through every single character, it will move on to line 15 and return false. That means there's no match. Okay, that's problem 3. Do not have an else block if it's not supposed to be there. Now, common problem number 4, I see a lot of programmers having unnecessary inner blocks. When I say inner block, it means a loop in a loop, or a conditional block in a conditional block. And if it is unnecessary, please don't do that. Now, in several circumstances, it is necessary to use nested loops and stuff like that. Okay, but If it is unnecessary, don't have inner blocks. Now, the reason is simple. The objective of, as a general rule of thumb, the code you write should be readable, easy to understand, and hence easy to debug. It is more difficult to read code with nested blocks, and hence more difficult to debug. So unless they are really necessary, do not have nested blocks. Let me show you an example. Problem 4. Now this chunk of code, the requirements will be to check if the value stored in hour is invalid, okay, meaning it is negative or it is bigger than 24, show an error message. Print this out, invalid hour. On the other hand, if hour is between 0 and 12, it means it's morning, print out good morning. If hour is from 12 to 18, which is 6 p.m., print out good afternoon. Else, for all other cases, which means it is after 6 p.m., it is 6 p.m. to 2400, which is 12 midnight, prints out good evening. Now look at this chunk of code, it works. The output will be correct based on depending on the value of hour. But the problem here is there is a nested if block here. And there's no need for it to be nested. That's the real problem. Now if you really need to nest. But I do not see a need to do that in this circumstance, and it makes the code difficult to read, it makes the code difficult to debug. It does not help to improve the speed or efficiency of the code at all. Now let me change the code a bit. I've done it. No nested blocks, and it works exactly the same way. Cleaner, easier to read, efficiency is the same. Okay, let's move on to problem number 5. Now, bugs related to casting. This diagram here shows the 8 primitive or 8 simple types in Java. From left to right, you're talking about a widening cast or a promotion. From right to left is a demotion or a narrowing cast. Of course, narrowing casts need to be explicit. So let me show an example of a bug related to casting. Problem 5 is... Now, I have two integers x and y. X stores 100,000, y stores 100,000, and I want to find the product. Now the product of x and y is actually 10 billion. And 10 billion is too big to be stored in an int. So you have to store 10 billion in a long variable. And that's what I'm trying to do on line 9. I declare a variable called product. The type is long. And after multiplying x and y, I'm going to cast the answer to a long and store it in product. Alright, if I try to run this program, the output is going to be wrong. Let's try it. You see, apparently line 10 prints out a wrong value. So the value stored in product is smaller than 10 billion. It's a smaller value than 10 billion. Now, why is that the case? This is the problem. You have to understand that an integer multiplied by an integer will result in an integer. Which means that what I've highlighted, this part here, already stores a wrong value. Okay, a value which is smaller than 10 billion, because you can't store 10 billion in an int. I cast it to a long too late because the value is already wrong. I cast it to a long and store it in product, and that's the reason for the output. Now, how then do I solve this problem? Quite simply, just do this. Let me save this. Okay, compile this and run it. This time I get 10 billion stored in product. Why? Now, what I've done here is I'm casting x to a long. And I'm multiplying the long value with another long value. A long multiplied by a long gives you a long. More than enough space for storing 10 billion or a larger number, and that's why the answer is stored, the value stored in product is correct. Now there's actually no need for you to cast both x and y to long types. This will work as well. You just have to cast one of them. Okay, because in this case a long multiplied by a int will result in the int being promoted. This becomes a long multiplied by a long. Answer is still a long. Okay. Remember that the cast operator has higher precedence than the multiplication operator, so there is no real need to use brackets to force a cast. Although now this is correct as well, although it looks quite weird. There's no need for this brackets. The cast operator has a very high precedence. I think the highest precedence in a table of operators. So be careful when you're doing casting. Now problem 6, integer operations that result in unexpected answers. Kind of related to problem number 5. Let's look at one example. I'm trying to calculate the area of a triangle. So base is 10, height is 5. And of course the formula for the area of a triangle is half times base times height. Looks innocently correct. But in this case, when I try to run the program, 0 gets printed out. 0 gets printed out. And why is that the case? The bug lies here. The problem lies here. 1 divided by 2 is an integer operation. An integer divided by integer gives you an integer. So 1 divided by 2 is not 0.5. It's actually 0. So of course 0 times anything will give you 0. The answer multiplied by anything will still give you 0. So area in this case will always be 0. So how do you solve this problem? Can be easily solved by doing this. Okay, 1.0 divided by 2 will be 0.5, a double. So double times base, regardless of what is the type of base, will be a double. And that double multiplied by height, okay, will be a double, which is stored in area. So in this case, you're going to get 25. Alright, so some of you may say, okay, why not just do this? This will definitely be correct. I'm just giving an example. Okay, so be very careful when you have an integer divided by integer. Okay, it may result in inaccurate answers. Okay, the values after the decimal point is thrown away, or in this case, it results in an answer which is totally wrong. Now, problem 7, inefficient code. Your output may be correct, your behavior may be correct, your code behavior, but it may be written in a very inefficient way. For example, you have unnecessary looping, or you have repeated statements in your if and else block. Let's look at an example. Problem 7. Okay, this example shows unnecessary looping. Okay, this may look familiar. The contains char method which takes in a string and a char and returns true if the char C is found in the string S. So the programmer has approached the problem a bit differently. He declares a local variable called status, sets it to false. Status will be returned at the end of the method. Now the for loop goes through every single character in S. So if S is a 1,000 character string, this loop will happen 1,000 times. Alright? Then it checks. During the first iteration, it checks char at 0. Is it C? If so, set status to true. If not, don't touch status. Increase I by 1, checks. This is still true. Checks the second character. Increase I by 1, this is still true. Checks the third character and so on until all every single character in S has been compared with C. And at the very end on line 17, after the loop has completed its full run, it returns the value in status. So if there is never a match during the loop, status will be false. Okay. Now this works contains char will return the correct boolean, but it is very inefficient. Now, if S is a 1,000 character string, okay, and its first character happens to match C, this is going to happen 1,000 times still, and it's unnecessary. Okay, so what can be done is get rid of this. There's no need for a boolean. I simply have to check. Once there is a match, I'm going down the chain right in the string S. Once there's a match, I'll return true immediately, terminate the whole method. Okay, if there's no match, I'll carry on checking the second character. No match, check the third character. No match, check the fourth character, or so on and so forth. Until the 1,000th character, still no match, jump to line 16 and return false. Okay, this example of, when the method has found the value to return, just return it. Don't carry on looping unnecessarily. So another example of inefficient code to be found here. So the business rule here is to check if this person can enter the pub. So the rules of the pub, only males who are above 21 years old or females who are above 18 years old are allowed. So a 19-year-old female can enter, but a 19-year-old male cannot enter. Right? So let's assume that Ismail is true. Okay, this can be actually read from a database, it can be prompted, etc. So there's an if block here. Let me check to check if Ismail is true. If Ismail is true, I prompt for his age, okay, get his age, and I check if his age is bigger than 21. If so, you may enter. If not, you may not enter. On the other hand, if Ismail is false, that means I'm dealing with a female. I jump to the else block here, and on line 27, I ask for the age, get the age, store it in the variable age, and check if age is bigger than 18. Because in this case, I'm only interested if is the female is a female, right? Above 18, you can enter. Print, you may enter. If not, print, you may not enter. Chunk of code works, but a sharp R will immediately, you know, um, tell you that something is wrong. What is wrong? Repeated code. Line 16 to 17, lines 27, 28, repeated code, and they are in mutually exclusive blocks. So one is in the if block, one is in the else block. So pull this out. They shouldn't be in the if or else blocks at all. Okay, that's it. This is much improved. Before the if or else block, I just ask for the age, store in a variable age. Okay, if Ismail is true, I'll check age. If we're dealing with a female, okay, let me get rid of this. I'll check age. Okay, in fact, this piece of code can be further improved. Um, and this is how I can do it. Is male and age is bigger than 21. Or not is male, that means female, right? And age is bigger than 18. Print, you may enter. Else you may not enter. That's it. Okay. this will work as well. So I'm checking if this condition is true or this condition is true. I will allow entry. Otherwise, no entry. Okay, only males above 21 years old, females above 18 years old. Not is male means, is male is false. They mean the same thing. Okay, so just be very careful when you see repeated code in mutually exclusive blocks. That chunk of code should not be there. Okay, let's move on. Common problem 8. Obfuscated code. So obfuscate something means to make it look, to confuse it, to make it look difficult to understand. So obfuscated code is code that may increase the chances of bugs and misunderstandings. Let me give an example. Now, on line 6, I'm checking for two things. Alright, if has valid road tax is true and is insured is true. Is insured is actually a method call. It's actually a method, so it returns true or false. So only when both conditions are true, I will allow the car to be driven. Otherwise, the car cannot be driven. So let's look at the is insured method. Now, is insured returns a boolean, and this is an assumption. Okay, the value in paid up can probably be read from a database or read from some record. Doesn't matter. Now, if paid up is false, the method is insured actually sends out a reminder email. Okay, in this case, I'm just printing a statement onto the screen to simulate that email has been sent out. All right. So what's the problem with this piece of code? This is a short circuit AND operator. Now there are two AND operators in Java, right? The normal AND operator, a single AND, and a short circuit AND operator. So normal AND operator, logical AND operator. Okay, and the short circuit AND operator. The difference is that if you're using the short circuit AND operator, now this is the operand, and this is the second operand. Operand 1, operand 2. Now for the short circuit AND operator, if the first operand is false, it will not evaluate the second operand. There's no need to actually, because if the first operand is false, the whole expression returns false, regardless of what is O2, what is the second operand. Alright, so the behavior of the short circuit AND operator is such that there is no need, and in fact, the program will not evaluate O2 if O1 is already false. But if O1 is true, it will check O2 to determine what will be the whole expression. Now the normal AND operator, if you use a normal AND operator, both expressions, both O1 and O2 will be evaluated, regardless of whether O1 is true or false. So in this case, do you see that we are using the short circuit AND operator, and because of that, whether is insured will execute or not depends on the value of has valid road tax. If has valid road tax is true, is insured will run. If has valid road tax is false, is insured won't run. Okay, because the whole expression will immediately return false. Now the problem lies in the fact that is insured does something. In this case, in this example, in this contrived example, it sends out an email to remind the driver to pay insurance. Not road tax, but insurance. Okay, is insured can be any method which changes state as well. So if you have understood what I've said, basically it means that whether the driver gets an email reminder to pay insurance depends on the value of has valid road tax, which is very strange and is probably not what the programmer intends. Okay, so this is an example of obfuscated code. Um, Especially if is insured does something, it changes state, it sends an email. You're not sure whether that method runs or not. Depends on the value of this has valid road tax. Okay, it can cause bugs, it can cause misunderstandings. All right. Sometimes the email gets sent and you're wondering why. Sometimes the email does not get sent and you'll be wondering why. So try to avoid such situations. That's problem 8. Problem 9. Mixing spaces with tabs may result in unintended indentation problems. I'll show an example. I'm running Notepad. Let me increase the font size. Okay. Public class dump, just for demonstration purposes. Let me write a static void main string args. Okay, I have two print line statements. Now, notice that I'm pressing tab now. Oh, okay, tab is set to 8 here. Okay. Now let's look at this. As far as the reader is concerned, it looks perfectly indented. Alright, these two statements are on the same line. I mean, they start off on the same vertical line. However, in front of this statement is 2, 3, 4, 5, 6, 7, 8 spaces. Are 8 spaces. But in front of this statement number 4 is actually one tab. Not spaces, but one tab. It looks perfect here. Let me save it to my desktop. Dump.java. And let me open dump.java using another editor. Okay. I've opened it using Notepad++. And notice that there is an indentation problem here. Why? Now, on line 3, I still have 8 spaces in front of system. On line 4, I still have one tab in front of system. Why is there a difference? Exactly the same file, but they look different in different editors. Now, the reason is because tab can be configured to display as a different number of spaces depending on the editor. So for Notepad, a tab is displayed here. A tab is displayed as 8 spaces. For Notepad++, now this is actually a setting. Tab settings. I can actually set the tab size. So in this case, a tab is displayed as 2 spaces, and that's the reason why line number 4 looks so strange here. Now if I change that tab setting to 8, it will look correct, but there's no guarantee that, if you're submitting this code for someone else who is the assessor, it is what he sees which matters, not what you see on your own laptop which matters. So if you mix tabs and spaces when you do indentation, you might run to this problem. Someone else's editor will have a tab setting which is different from your editor. So the general rule of thumb is do not mix spaces with tabs, like what I've done here. 8 spaces, 1 tab. They look perfect on your screen, but they may look wrong on someone else's screen. Use tabs all the way or use spaces all the way. Okay, choose either one, but don't mix them. I've shown you the reason why. Now, some editors has this very nice feature. For For example, Notepad++ has this nice feature, replace by space. If I check it and I close it, after editing, when I save a file, okay, they replace the tab character with spaces so that it will always look correct in some other editor. Spaces will be safe. Spaces are fixed spaces. Alright, so do not mix tab spaces when you do your indentation. The last common problem is the strange behavior of next in of scanner. Let me show a bit of code which explains this. Very common problem, very specific to the scanner class of, Java. Now I've created a scanner object, okay, which reads input from the keyboard. On line 7, I'm prompting the user to enter a number. I'm using next int of the scanner object to retrieve the integer, which is stored in this variable called input1. On line 10, I prompt for a word, and I'm using next line, okay, to retrieve that string, which I then store in input2. And of course, on line 13, it just prints out you have entered, input1, which is a number, and input2. Very innocent piece of code. What happens when it runs? Enter number 8. Hey, it didn't even give me a chance to enter my word. It seems to have skipped line 11. Why? Well, the reason is because next in of the scanner object, it reads the number, in this case 8. What have I entered? I've actually entered two characters, 8 followed by an enter. Enter is actually treated as an entry, as part of the entry as well. I've entered two characters, not one. And a next in method only removes the number from the buffer and leaves the enter, which is a new line character, in the buffer. And the next time it calls the next line method of scanner, it simply returns immediately because it reads the new line character in the buffer. Okay? And there's a reason why it did not give me a chance to enter my word. So what should have been done here to avoid the problem is to flush the buffer. And if you insert such a statement, it'd be nice to insert a comment here so that any reader will understand why what I'm trying to do here on line number 10. You're trying to flush the buffer because the next time you're going to use next line. Alright, let me save this and let's see if it works. Let me compile it first. Number 8, you see, this time it waits for me to enter a word. You entered 8 and apple. Now there's no need to flush the buffer if you are reading consecutive integers. It is only necessary if you have used next in and then you want to use next line after that. Alright? This is a very Java specific weird idiosyncrasy. Now, we are not going to discuss other O-related common problems at this stage because this will be material for another session. Okay, as you become more advanced and you learn about O principles. And that's the last slide I have for you guys. I hope you have enjoyed the session. Thank you.